Hello, everyone. This is Dr. Gallenstein. Welcome to the R Studio presentation of how to implement lecture number one. So you've already watched lecture number one, and with it you've seen the Stata tutorial. So this is just a follow-up on that. Basically, how do we perform those same operations, the same descriptive statistic analysis, so to speak, in RStudio. So let's just jump right in. This will be brief. So when we're using RStudio, as I showed you in the tutorial, we have our script file, which has the code that we want to run, the global environment that shows us the data sets or the variables that we have. Any plots we might produce will be down here, and then any other output that we produce will be down here. Well, let's just go ahead and implement this and see it in action. And as I go through it, in this lecture as in future lectures, I'll explain a few little things more about R. There's actually quite a bit of nuances or complexities to using R. And so we'll just kind of, learn little bits of it at a time, a little bits in every lecture. So here we go. Lecture number one, Descriptive Statistics. So one important thing about using R, the way that R works is that what you will do is you will execute a command. You'll give R a command, and that command will tell R to perform some operation and produce some output. Okay, so I showed you before I can summarize a data set by using a command summary. So that was in the tutorial. I'll show you that in just a moment. Now, there are a lot of commands in R. There's a lot of commands that are available to users of R. Now, some of these commands are built into R. They just exist. They just exist as a part of the software package. As soon as you download it, those commands exist. Summary is one of them, as I showed you from the tutorial. But there are other commands that are written by other R users. I mentioned in the tutorial that R has a large community that surrounds it. It's open source, so anyone can write code for R. They can create commands for R, and then they make them available and other people can use them. And so as we use R, we will very frequently use commands that were written by other people, experts at R. And so what we will need to do is we will need to access those commands, the commands that are written by other R users. And so those things are called packages. So in R, we have this thing called a package. A package is a collection of commands. And like I said before, there are many packages or many commands that are just built into R. As soon as you download it, you get it. But there are others that we might need to use that are not built into R, so we need to install them. And this is where we get this idea of installing a package. You'll see this throughout the course that you will need to install packages so as to use particular commands in R. If you want to know what packages you already have, you would click on the Package tab down here. And this gives you a list of all the packages that you have in your software. Now, if you've just downloaded it and you scroll through it, you'll find a lot fewer than mine. I have a lot more packages because I've used R for longer and I've installed more packages. But as you go through this course, you will accumulate quite a number of them. You'll see next to it is a user library. This tells you what packages you're using at any given time. And you'll see little check marks next to all of the packages that are being used. For yours, you might not see very many, but you'll see for mine that there are a number of different packages that have a little check mark next to it, which means I'm currently using them. Okay, so the first thing that you need to do is you need to install some packages. We're going to use a number of packages today, so please go ahead and write these down, install packages. One nice thing about R is that as you type, it will sometimes give you a recommendation of what it thinks you want to add. So you could just do install packages, and then you just type in the package that you want to install. Notice that you'll want to have it in quotation marks. Now, one interesting thing about R is that you can have quotation marks, that is the double, or just single. Either way works, they're just identical. So you'll just type in the name of the package that you want. You'll highlight it and click Run. I'm not going to run it because I already have it installed. But you know what? It actually doesn't hurt. So I'm just going to run one just so you can see what it looks like. So sometimes when you run install packages, you'll need to restart R. It's really you'll get a little message or a little I don't know, a little message like this. Just click yes. It really doesn't do anything. I mean, it restarts R, but it doesn't mess you up. Okay, so it's actually quite simple. All right, so it went ahead. It's installing it now. You'll get some of this blue lettering. You'll get a pop-up. You'll get this thing that says warning. Don't worry about warnings. What you're really looking for is down here. It says package Haven successfully unpacked and MD5 sums checked. So here we go. We're done. That is now installed. Now it was already installed on mine. It doesn't hurt anything to just reinstall something. For yours, you won't have it, so you'll have to run all of these and install those packages. Throughout the course, we will be installing a bunch of packages. So we'll just kind of get used to that. Usually, I'll tell you what packages you need to install early on in a lecture. All right, so now that we're done with that, let's go ahead and import our data. Now I'm going to use, okay, so here, let's clarify this. We've installed packages. We've installed a package called Haven, one called Tidyverse, one called Psych, one called Epidisplay. Now, once a package is installed, I have to tell Stata that I want to use it. And the way that I tell Stata that I want to use it is by using this command library. So now I'm going to use these two packages. These two packages will be important for me when I go to import the data. So I will just highlight those and I will hit run. And that tells Stata to allow me to use those packages. So here we go. I ran that. Now let's import our data. So here's a line of code that allows me to import data. Now I need to give it a name. So I'm going to give this data set the name wages because it's going to be the data set we've already seen on data on wages and some factors that might influence wages. So I'm going to give the name of this data set wages. I'm going to use this little arrow here. This arrow, you can see the arrow is pointing to the left. Basically what it's saying is that this line of code here is what is going to be used to define this variable or this data set that has the name wages. So that's all that means. It's just the same thing as an equal sign, basically, if that is a little bit more intuitive. But this is the conventional notation in R. So wages, this arrow, and then I'm going to use a command called read DTA. DTA, that's the data type for Stata. And so all I'm doing is I'm just importing the same data set, the same Stata data set that I used in the other demo, but I'm just importing it into R. So this command read underscore DTA, it's a command that tells R to import a Stata data set into R. And then all I do is I just give it the file pathway on my computer. This so happens to be my file pathway. You'll have to look on your computer to determine the file pathway on yours. You should have downloaded wages from the course website. And then put in your file pathway that takes you to where you have the data set saved on your computer. Put that in. Note that you need 2 backslashes in R. If you type it in, you might accidentally do 1 backslash. You'll need 2. Okay, so I'll just run this. That'll give me my data set wages. I can click on it, see my data set, see it's there, see the labels there. So everything looks good. Let's proceed. Okay, now we've already looked at the data, so I don't need to go through it. You've already seen the Stata tutorial. So let's just take a look at a couple of helpful commands that will allow us to just get an idea of what our data is like. Okay, whenever you're doing a data analysis, one of the first things that you want to do is you want to look at your data, look at what variables you have, and get a feel for it. There's a number of helpful commands in Stata that just help you get a first look. So I'll go ahead and do this one first. str. Okay, this is short for structure. So I'm just going to do str, and then I'll put the data set in there, wages. This will show me the structure of the data set. Now, structure, what that means is it shows you the type of data that it is. Okay, so here we go. This shows us the data has 526 rows and 6 variables. We already know that from over here. It's the type of data set is called a data frame. I won't go into the details of that now, but it's helpful to know that it's a data frame. Okay, and then here you'll see all the different variables. So wage, education, experience, non-white, female, and married. And then for each one, it shows you the type of data that it is. So NUM, that's short for num, or it's num, it's short for number. It just tells you that the type of data that it is a number. There are other types of data. We'll encounter them as we go through the course. It shows you the first handful of values. You can see that this number variable goes from 1 to 2, so to 526. It has a label, hourly wages. It shows you what the label is there. Okay, it just goes through and shows you the structure of the data set. You can kind of peruse that. Another helpful one is head wages. What it does is it shows you the first shows you the first 6 observations from the data set. So it just shows you a little excerpt of the data. Sometimes that's helpful. It's just a way to give you a feel for the data right there in your console. Another nice one is summary. We've seen this before. Summary shows us a handful of summary statistics, including the min, median, mean, and max for each of the variables in the data set. Okay, but now if we want to produce a nice descriptive statistics table, as we've already looked at in R, we're going to need to use the psych package. So I'll click library psych. That tells R that I want to use the psych package. And I'm going to use this command describe. This command describe comes from the psych package. So I'm going to use the command describe wages. And now what it's going to do, it's going to take all the variables in my data set and provide a very nice range of descriptive statistics, including everything that we need to report descriptive statistics in this class. So sample size, the mean, standard deviation, median, the min, the max, range, and standard error. So this is really a fantastic command in terms of generating descriptive statistics. Okay, now as we also talked about, sometimes, actually I would say all the time, when we open a data set, that one of the first things we want to do when you're going to do some analysis, I do want to impress this, when you're going to do some analysis, it is an incredibly good skill to just familiarize yourself with your data. You can look at the data, you can generate some descriptive statistics as we already shown. It's also really nice to graph it, to visualize it, to get a feel for it. Okay, and so in order to do that in R, we're going to use a package called ggplot2. ggplot2 is just a very helpful, very commonly used package among R users for creating very nice data visualizations, nice plots or images. So I'll just tell R that I want to use ggplot. Okay, and then I'm going to generate a couple of graphs. So the first, I'm going to generate a histogram. And then I'll do a kernel density function, or aka an empirical. It's just kind of 2 different ways of generating empirical distributions. I'm just going to look at the wage variable. Okay, so let me walk you through this. So here I have the code that we need to generate a histogram. Now in R, when you generate a plot, you actually give the plot a name. You name this data object. The data object is a plot. Okay, I'm going to call this PL, short for plot, underscore hist. So this is just the name I'm going to give it. You could give it any name that you want. You could name it John. You can name it whatever you want. I'm going to call it PL underscore hist, okay? And then I'm going to define this, okay? Basically equals to this arrow. I'm going to define it as this, and here's the code that we need to generate this plot. So ggplot, that's the first command. And when you type in ggplot, what you need to put in fact, actually, I might even give you a comment here to kind of explain what this is. So name, okay, ggplot command, all right? You're going to put in the data set, okay, comma, AES. AES stands for aesthetics, okay, and then you're going to put in the variable that you want to plot, or 2 variables. In the future, we'll see cases in which we want 2 variables, okay. plus, and then you need to tell ggplot, you need to tell R what type of plot that you want to produce. And so we're going to use a histogram. So it's geom underscore histogram, and then just empty parentheses. Okay. This tells you the type of plot. So what I'm going to do is I'm going to run this line of code. And what that has done, you can see over here that I've created this data object plhist. But nothing came up. I didn't see any plots. All right. So all I've done here is I've created this data object plhist. All right. And now I just want R to print that for me. I want it to visualize it. So I just write it on another line and hit run. And then the plot comes up here. So there's our plot. Here's our histogram of the wage variable. Okay. If I want to see it bigger, I can click on zoom, and then it opens up a full screen version of it, and I can just look at it. Okay. All right. Now I can use ggplot to produce a kernel density, kind of a smoothed empirical distribution. So let's do that next. So I have a note here saying what I'm doing. This one I'm going to call PL emp dist, or empirical distribution. I could call it anything. You can call it anything that you want. I could call it the Dr. G plot. I could call it anything that I want here. It doesn't really matter. Okay. All right, so here we go. The only difference here is that instead of doing a histogram, up here, histogram, here I'm going to put in the name geom density. That tells it to produce a density plot. So I'll just run this line of code. You can see that this data object, let's see what I do here. Okay, run this line of code. Okay, there we go. Run the line of code. You can see that it created the data object. Now I just want it to print it. And there it is. There we have our nice, kind of our smoothed empirical distribution there. Okay. All right, the next thing I want to show you how to do is how to generate correlations. All right. So I have a couple lines of code here just in case. Here, we can actually skip some of those lines of code for now. I'll just type in core wages. And what that's going to do, oh, whoops, it's just one R. Okay, and what this has done is it's given me a correlation matrix between all the variables in my data set. So if I want the correlation coefficient between wage and education, here it is. Between wage and experience, here it is. Between, okay, so as you can see, it has all the different data variables in the data set and all the correlations between them. This code is a little bit more than we need here. So just core wages. All right. Okay, next we have frequency table. All right, so now what if I just want to produce the frequency of different observations in the data set? Okay, so I just want to know how many times the different values of a variable show up in the data. So for example, the married variable, it takes on two values. It's a binary variable, or what we call a dummy variable. It takes on two values, one for if a person is married and zero otherwise. Well, what if I wanted to know how many times is the married variable 1 versus how many times is the married variable 0? I can use a frequency table to produce that. Now, there's a very nice command for producing a very nice frequency table, and it's in the epi-display package. So I'm going to click library epi-display. I'm going to tell R that that's the package I want to use. And then I'm going to use this tab1 command. And in this tab1 command, I'm going to tell R what variable I want it to use. And then I'm going to give it some other information here, which we don't necessarily need to go into tremendous detail about now. You'll be able to just copy and paste it. So I'll just run this. And here I have a nice table, very nice presentation table, very nice frequency table, and actually gives us a corresponding graph. So we have for when the married variable equals 0, there are 206 observations. And then for when the married variable equals 1, there's 320 observations. This shows you the percentage of each of those categories. So 39.2% are non-married and 60.8% are married. Of course, that adds up to 100. And then it shows you the cumulative percentage. And the total sample size, as we know, 526. Okay, now a quick note. I use this command to tell it to create a frequency table for the variable married. Notice how I did it though. I'll just do this in a command. If I want R to compute something about a variable that is inside of my data set, I need to communicate it differently. R works a little bit different from Stata. You can see over here in the global environment that I have listed the data set, but it doesn't list the actual variables that are inside the data set over here. So what I need to do is I need to tell R that I want a variable from the wage data set. Okay, so I put wage first, and then the $, and then I write the variable. So in our language, what this is saying is that I want the variable married inside the dataset wage. Or sorry, it's wages. So this is the way that R works. You give it the data set first. You have to specify the data set, because in R you actually can have multiple data sets in your global environment at a time. That's a difference from Stata. In Stata, you can only have one data set at a time. In R, you can have tons of data sets at a time. So in R, you have to specify what data set the variable comes from. So you would write wages, and then you use this $, to indicate what the variable is. So you can see that here, wages. So we're telling I'm going to apply this command tab 1 on the wages data set for the variable married. Okay, so I just want to clarify that. That'll come up again and again, so you don't need to worry too much about that here. All right, and then finally, I want to show you how to do a conditional mean. All right, I'm going to use the dplyr library here. It's another one of the packages. We installed it earlier. Oh no, we actually didn't have that. I already have it, but I didn't write it here. So package dplyr. Okay, so you install that on yours. So I told it library run dplyr. Okay, and dplyr has a lot of features in it. I'm not going to go through all of it in class. You can go to YouTube and learn more about it. It has a lot of neat data analytics features. But for now, just bear with me here and use this command for producing some conditional means, which we know we need to be able to do. When using the dplyr library, I can just state the data set I want to use. This symbol, the symbol means you're applying something to the previous object. So this symbol means I'm going to take the, I'm going to do group by female. So I'm going to group the data by the variable female, group the wages data by the variable female, and then I want to use this summarize command, and it'll produce the a new variable mean wage fem, which equals the mean or the average of the wage variable. You don't need to understand all the details of this right now. You're going to get more comfortable with using R as we go, but let me just run this. And so what we've done here is we have this variable female 0 or 1, and then we have the average of that variable, so the average value of the wage variable for the different values of the female variable. So here's the average wage for when the female variable equals 0, and here's the average wage for when the female variable equals 1. Okay. All right, so there we go. We're done with the Descriptive Statistics lecture in R. Good luck practicing, and good luck in class, and I will see you next time.